Good morning, friends. Today we're going to learn about how to use Scilab. Scilab is basically used for calculation purposes and for making graphs. Today we learn how to use the Scilab for the NTG tool. Like this is the Scilab. Click over there. This is a console window. I am using Scilab 5.5.2 console. Here we can use some basic operations also. In this console window you can type 12 plus 8 12 plus 8 bracket close divided by, you can write here anything like 3.5. You got the answer. Likewise you can do the square root also. Square root, like you can use 25. Here is the answer. And at root you have to pass the arguments over there. For the root we have to find, like I want to find for the fourth. Here is the answer. So this is how we can use it. Basic. It's just, guys, this is just a basic. Now you can click on this question mark application here. You got this. This is the Navel. Navel is the network topology generator we can use for the networking purpose. Here there are some introductions, like you can use it for functions, graphs, internet, mobility, routing. I am using for routing. Like if I want to do this Dijkstra algorithm. Basically what is Dijkstra? First I'll tell you. Dijkstra computes the shortest paths between all the network nodes of the graph G towards a single source I in respect with the Dijkstra's algorithms. The graph is assumed to be weighted. The edge weights must be positive. The graph edges of the current node neighborhood are relaxed. The internet displacement of the current node propagates minimum distances through the network. N corresponds to the network size. The vector D of size n provides the total distance between each network node and the source node I. The vector P of size n gives the predecessor node of each network vertex in order to reach the source node according to the shortest path. Like here we can see this is the calling sequence. D is used for the graph vector of the total distance between each network node and the source node. P is used for vector composed by the predecessor of each node in order to reach the source node. Guys, in this Dijkstra, as we know, the source node we have to take to reach the all other nodes. Source node is the predecessor of the graph, and initially we have to declare the source node as a 0. Okay, here is a pseudo code function. First we have to take this Dijkstra and pass two arguments, that is the graph and the source node. Without source node we can't explain the. For each vertex v in graph, distance v equals to infinity. Unknown distance function from source to v. Previous v equals to undefined. Previous node in optimal path from source. Distance source equals to 0. Q equals the set of all nodes in the graph, means all nodes in the graph are unoptimized, they are in Q. While Q is non-empty, U equals to vertex in Q. Q is non-empty because while we are taking, this is the initial point, guys, while we are taking, we all source node should be 0 and all the other nodes should be infinity. So we are finding the vertex in Q with smallest distance. If distance U is equals to infinity, then we break. All remaining vertices are inaccessible from source. Remove U from Q. Okay. For each neighbor V of U where V has not yet been removed from key, alt, we can gonna put this distance U and distance UV. We're gonna add these two and put it in this variable. If alt is inferior to distance V, we're gonna relax all UVA. Distance V equals to alt, previous V equals to U, return distance. Now we're gonna learn about how to run the program. Like here is a sample code. We're gonna copy this, print here this application, sign notes, Control V, and this is the run button. Press on this, save and execute. I'm gonna save this P1. Save. There is the answer. NTL locality connects. This is the window where we're going to show graphs. This is the y-axis, this is the x-axis. These are the nodes, and these are the weights of the nodes, the number of nodes also. Thank you guys. This is the Scilab video. If you like it, please go on the my channel.